Okay, so I'm Chris Norman, I'm the Engineering Director for AAX. I will tell you a little bit more about what AAX is shortly. Is that working? There we go. So I hope everybody knows who the AA are. We are the #1 roadside provider in the UK. We've been voted best roadside provider by Which for the last 6 years. We're very proud of that. We've been around for nearly 120 years now, and we are always focusing on the driver experience, and we've been focusing on innovation with vehicles for our entire lifetime. In fact, the AA was the first petrol station. So we created the first petrol station in 1919 in Aldermaston in Berkshire, and we've been innovating on things all the way through. So we do lots of engineering innovation with our patrols to make the roadside experience better, and now we are focusing on innovation around the connected car space. So AAX was created within the AA to build the next generation of connected car businesses for the AA. We are trying to reinvent the car ownership experience for consumers and for businesses. And we partner with some of the world's largest and most innovative companies, and we also partner with smaller specialist providers as well to ensure that we are getting the best of the best and innovating and building our own things when we need to, but buying in and working with specialists in particular areas as well. The AA has some really great data. So we've got an awful lot of data that we've collected over the last few years. We've had connected car businesses in the past, and we've got over 800 million, well, it's actually closer to 1 billion data points at this point, from our connected vehicles. And that's consumer vehicles, but also our fleet of vans, our driving school cars. We are collecting an awful lot of data every day. We also collect a lot of weather data, and we combine that down to some really interesting data sets. We also go out to 10,000 breakdowns a day and collect data from those, and we've got 15 million breakdown incidents to draw on from the data that's been collected in those. So our patrols are collecting that data from the vehicle at point of breakdown, and we can use that data in our data sets. And we have a network of garages. And we've got about 40,000 reports from repairs in our Prestige garage network that we have read in. We've used a lot of computer vision to take handwritten notes from mechanics and actually generate data sets that allow us insight into what was actually wrong with a vehicle when it went in for repair. And we have a bunch of other data from our portfolio of businesses. So driving school, we have a significant amount of data from when people are driving. Our drive tech business also does driver training with the police and other emergency services. They also do analysis of driver behavior in TfL and other bus companies. So all of that data is available to us, and we have an accident management business as well. So again, where accidents have occurred, we have data on what caused that accident, and where it was mechanical failure or some other fault with the vehicle, that is a data set that we can draw on. So connected car data is specifically, and I'm sure the guys at Toyota know this very well, it is sending data in real time from the vehicle, and it's a lot of the data about the engine, the detail about the trip, so GPS data, that sort of thing. And there are additional ways to get that data. So we have got access to some data in CarPlay and Google Automotive, and a lot of commercial vehicles in particular have plug-in or wired-in devices that collect data from various providers. So that telematics data has been used historically for things like vehicle tracking, ensuring that drivers are in the right area, that sort of thing. Those are also gathering various types of data about the way vehicles work. Connected car is the future. This is the way it's going to be. Right now, 50% of new vehicles, slightly more than that now, are connectable, and it will be 95% plus by 2030. And the amount of data that is coming through from vehicles is going up all the time. Internal combustion engine vehicles generate about 1 megabyte of data a day. But when we look at EVs, that's a huge amount of data that is being generated, around 10 terabytes a day. And then with autonomous vehicles, that could be 45 terabytes or more of data that's being processed. So the ingestion of that data is a challenge, and the signal to noise of that sort of data as well is incredibly difficult to work with. So the automotive industry has lagged behind some other industries, but they're rapidly catching up. The transformation does require the manufacturers to come up with additional ways of monetizing this data. So that is starting to happen, and I think the OEMs that we're working with are definitely seeing where they can have value and add value to customers. The customer expectation gap is quite high, and I think that is a gap that needs to happen, needs to be addressed. Right now, I think that customers will expect that more data is available than actually is available. But there's regulatory pressure. The EU Data Act will be coming in soon, and that is going to start to apply pressure across the industry to open up that data. In a similar way to the open banking legislation in the EU has opened up that data, there's going to be pressure across the EU, and hopefully that legislation will be followed in the UK as well, and that will open up the access to data. So that will be huge. We are seeing additional technological advancements with things like CarPlay 2, additions to how Android Automotive is working, and Android Auto on top of it. So we're starting to be able to gather data, telematics data from those platforms in addition to the OEM data and the plug-in data that we have access to as well. And I think the industry is starting to learn a lot of lessons from other areas where they've started to use data. So aviation has been a heavy user of predictive maintenance, so getting real-time data from aeroplanes to work out what is wrong so that they can get planes turned around. Ryanair famously have a 15-minute turnaround time, so they want to make sure that if they need to do repairs, they can get the parts to the right place at the right time to fix the aircraft, to get it back into service. Similar problem across automotive fleets. So I think that a lot of the industry is starting to catch up to what predictive maintenance can do. The data is non-standardized at the moment, and that's a huge problem. The AA actually has a joint venture with ANWB, who is the Dutch car club, and Driven is the joint venture, and Driven are working to standardize the data sets that are available from the various OEM and plug-in telematics providers. With the third-party devices, the data quality and the consistency of the data points coming through can be a challenge. And the coverage of the vehicle and the compatibility of those data points is very challenging. With OEM embedded, there is very rich data, but the question is whether we're getting that in truly real time or whether we have to query it in a pull fashion rather than a push fashion. And I've talked a little bit about the EU Data Act as well, so that is also a factor for OEM that will hopefully standardize and make that data more available. So the use cases for this sort of thing are proactive maintenance to provide insights to prevent a breakdown, reactive maintenance so that we can work out what needs to happen when an incident has occurred, so we can get the right parts for your vehicle to get you back on the road more quickly, preventing surprises with scheduled maintenance, and for the driver to provide insights into the way they drive so that they can be better, safer drivers, also more eco-efficient, and give them insights into how to save money by driving better in their internal combustion engine cars, and potentially give them insights into what savings they could have by making very small behavioural changes in the way they work with their vehicle. So for AAX, we have two ventures currently in the market. Vixa is our B2C vehicle health product. We've just launched that a few weeks ago. And we have Vixa Pro, providing vehicle health insights across fleets. And we are using that with our fleet of yellow vans as well. And we are then looking at what future ventures we can do. But we're also facing internally. So what can we do with this data to make our existing businesses more efficient? So we're looking at the roadside of the future. How do we use connected data to give better information to our patrols at point of breakdown? Make sure that we get the right patrol to the right vehicle at the right time, ensure they've got the right tools and diagnostic components on the vehicle, potentially even work out before the patrol gets there that actually this is going to need to be a recovery rather than a roadside repair. And obviously we have an insurance business as well. So how can we work this data in to provide insight into the way people drive, to then apply that into our risk models for insurance? And then obviously we are looking at sort of global drive to net zero and EV adoption. So how do we use this data across the board to promote adoption of EVs? And we're underlying that with our AAX platform. So that's our data, the products that we're doing with our ventures, the internal platform, and our overall strategy work. And we are doing quite a lot of lobbying with the UK government and beyond on access to data and improvements in the EV space. So the areas of opportunity for us at the moment, these are the core causes of breakdown. So batteries, believe it or not, and the battery figure actually applies across internal combustion engine vehicles and EVs. The 9-volt battery in a vehicle is the #1 cause of breakdowns. People in EVs tend to ignore the 9-volt battery. And if the 9-volt battery fails, you can't start the vehicle, even if you have a full charge of your core battery. Engine faults, the next one. Tyres, the next one. So these are the three things that we're focusing on. Battery and engine we have out in the market at the moment. Our tyre model is being worked on. So the predictive battery model, we actually take data from the vehicle, and that is battery crank data, and we build a profile of your battery, and combining that with other data that we have available, including weather data, trip data for how you're driving. So length of trip matters with 9-volt batteries, give the thing a chance to recharge. So if you're taking lots of very short trips, that can impact your battery health. So we can, with about, at the moment, around an 80% reliability, predict that your battery is probably going to fail in the next 2 weeks. And that has gone up in the last few months. And we are continually getting feedback and feeding back into the data model to increase its accuracy. The goal is for that to be a 95% plus accuracy within the next year. And we have built this data off around 4 million trips in the past 4 years from the 40,000 or so vehicles that we've had connected at various times. Our proactive engine model takes data from the plug-in devices or the OEM data that we have access to and works through the data sets that we have around repairs and breakdown at roadside to work out the probability of if this combination of fault codes and other data coming from your vehicle come together, there is a reasonably high likelihood that this is the repair that is required. So not only can we do that, we're obviously the AA, so we can actually take you from insight to action as well. So we can provide you then with access to either a mobile mechanic to come out and fix the problem on your driveway, or we can book you into one of our network of garages, or we can provide that information to your mechanic as well to give them better insight into what is happening with their vehicle. And our next thing, we're actually working with a French company who are a specialist in tyre health. And they're using computer vision to work out the health of your tyres. So it will work out whether you have a wear pattern that could affect the safety of your tyres. And they're even down to the point of working out whether you have a mismatch of brands on your various tyres, and that can cause issues. It can throw off the balance of the vehicle. We will then be taking that computer vision data and that kind of point in time information and combining it with the data sets we get about the rest of the vehicle, about the way you're driving, your acceleration profile, your braking profile, to then have predictive data about when we believe your tyres will need to be changed, or potentially where they may be dangerous or problematic. That's a really interesting next step. And then, as I said earlier, we are working on providing behavioural insights for drivers. So how are you driving? Ecologically are you driving? And that's obviously important from a net zero point of view, but frankly, it saves you money. So if you can drive in a more efficient way, that's good for everybody. And if you're driving, if you can affect your driving by changing how you brake, how you accelerate, that will make you overall a safer driver. And the goal of the AA is obviously to make drivers safer. So, huge amount of vehicles coming online over the next few years. We're starting to see the level of data be sufficient to build a compelling product. It's still a very immature space, and the industry is obviously looking to solve those issues. And yeah, the insight isn't enough. That's the thing that we found. Just telling somebody that there's something wrong with their engine is interesting, but not great unless we can actually provide you with an action to take to resolve that problem. So that's what we're very much focused on. And we are focused on ensuring that we have partners in place where if we don't need to build a computer vision model to work out tyre health, then we will look at that and we will work with specialists in the area. But where we have unique data sets, we are very much focused on building those ourselves. There we go. Thank you very much.